This conference will now be recorded.
So there are topics, a lot of topics which are there. So today is the third last day, Ajay. Is it the third last day?
Seems our last day will be on 25th or 26th April.
25th or 20? How? What? Is it like seventh day of today? Is it seventh day or sixth day?
It was 10 days session
Yes, yes.
from
How?
15 to
Yes.
25.
When did it? 15. 15. Okay. One, because there was the off on Saturday, I guess, right? 15.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8. Today is the 8th. That means we have two sessions left. Yeah, two sessions are there.
Okay. Mm-hmm.
So two sessions are there. So what isn't it? I mean, like 15, 1, 2, 3, 4, leave Sunday, 4, 5, 6, 7, 8. Am I right or not? I guess that's, yeah. So what we will do, we'll look at the things that we can cover into the gradient descent, and then the last 2 days, I mean tomorrow and day after tomorrow, we will jump into deep learning if everybody is agreed to that. That is going to be a little more complex. So that's, we will look into deep learning tomorrow. We'll try to understand a basic idea, try to get the basic idea, and try to look at the simplest algorithm that we have. And then day after tomorrow, we will apply the deep learning to some of the data set that we have gathered, if everybody
Okay.
agrees to that.
Okay.
Yeah, we'll try to look into tomorrow's presentation, which is about deep learning. So we've covered so far, up till which point we've covered? Can somebody tell me? We've covered which point? Can somebody tell me, looking at your code, up till which point we've covered? Imports. This is no. Yeah. Tuple. Can you look at your code and tell me we have covered up till what point? Run all the cells. So today, if somebody have attended yesterday's session, so I guess they'll be able to pick up what we are going to start today. Local minima. Yeah, we were looking at the local minima and we did not plot it. Yeah, we supposed to do the plotting today. Superimpose. Is that right? We haven't done the plotting yet, right? We haven't plotted our graph. Multiple minima guesses. Yeah. Okay, yeah, we'll do the plotting today, and then we'll look into some other things, and let's see how much we can cover. Yeah, so we design a function basically for it. A new value of x indentation. Okay, yeah, I get it. Okay, leave it. Anyway, I'm not using this lines. I already have a function. Yeah, function I was talking about. Okay, then I created this function. So today also we will try to understand how this thing is working, how the three return statement works. Basically, this is a concept of tuple unpacking. We'll try to look at another data type, which is tuple. Yesterday, okay, yeah, I told you to cover these. Okay, today. Okay, no, gradient descent is not defined. Okay, I haven't run the cell. So I guess everybody have run those cells and we are all on the same page. Now we are going to do the plotting. We've covered up till this point. So this is something I'm going to break it down for you what is happening here. So I would request you all to work out the code, and I guess you already have this notebook with you, right? In which I have this code written. You already have this notebook. This was there. Yeah, this was there. Yeah, I guess, yeah. It was covered, I guess. This point was covered or not? No, it was not covered, no? Okay, yeah, this was not covered, I guess. Okay, just hang on, guys. Guys, have we covered this divergence and overflow? No, right? Have we covered divergence and overflow? No. So we haven't plotted our graph. We covered up till this point, right? This cell.
Yeah, 25th. Yes, 25th
Okay,
cell.
yeah. So exactly. So what exactly we have up till now? We have the local minimum value, which is coming out from these the running this function. We have a local minimum value, and we also have a list wherein I have all the values for the x, basically the new x, and then I have a list for the derivative list where I have the values for the derivative. And these are the parameters that I'm passing into my function, which is first one is my derivative function. Then the initial guess, I'm saying it's going to be 0.5. Then I'm saying initial guess is going to be 0.5. I want my loop to start from 0.5, which is 0.5, yeah, which is somewhere here. I want to start it from here. And what else I want to do? Okay, then I'm giving it the multiplier. Multiplier is something which is working out here, which is going to help me to take the next step. We will talk about this multiplier in depth today, that how does this multiplier affect my algorithm, and we'll talk about this in depth today. Yeah, so then I have a precision, that what is the precision I'm looking for, and yeah, and I have predefined that these are the maximum iteration I want my algorithm to run. So I think it's clear to everyone up till this point. We've tried multiple values, we've tried multiple guesses. We started at 0.1, sorry, 0.5. Then we have this local minima. We were able to achieve that 23 step. Then we tried starting from minus 0.5 in the negative direction, and we were able to get, we were starting from this here only minus, yeah. So we were able to achieve this point in 56 iteration. And the local minima is a same, but yeah, it's in the negative direction, one is in the positive direction. Then we started an initial guess at -1, which is very close to that. -1, 0.5. I mean, it's somewhere here. I mean, yeah, no, it's away from it. I mean, yeah, it's somewhere here at this particular point, and we are trying to reach to this particular point. So yeah, how much we are getting that? Let's see. Yeah, we are able to achieve that in 34 number of steps. So I am assuming that everybody is clear up till this point. What is the number of step, what is the derivative function is doing, what is the initial guess is doing, what is the precision is doing, and yeah, you have some idea about the multiplier, why do I have a multiplier, what is the reason of the multiplier and all that. I guess I'm assuming everybody is clear up till this point. Now see, visualization is always essential. Just because I am saying this is how it's working, it is at this point and it is going from this point to this point, you cannot believe me, right? Obviously you need some proofs for that. So yeah, that's what we are going to look at. If my point is at this point, how it is reaching to the minima, we will try to look at all these different things today. So yeah, let's look at this. So I am using my function at this particular point. I'm using my function at this particular point. I'm calling my gradients descent inside here. So the first thing that I want to do, I want to keep my initial guess at minus 0.5. That's what I want to do. I don't want to go to zero initial guess. Yeah, we'll look into this last. I want to start from 0.5 and I already have defined the other values. The other parameters are already fixed, which is the multiplier is fixed, the precision is already there, and the maximum iteration is also fixed. Now let's go back here. So the derivative function, I've defined it to dg. So dg, we have already seen dg. If you don't remember it, so yeah, let's take you back. Yeah, this was dg, which I asked you to calculate, which is the derivative of this particular function. And if somebody get confused at any point of time, please ask question right away. Please ask questions. Okay, now what I'm doing here at this particular point, now I am going to plot function and derivative and scatter plot side by side. This is what I'm trying to do. So I'm giving it a figure size of 15,5, and then I'm telling subplot 1, 2, 1, one row, 2 column, and first plot. What is going to be my first plot? So my first plot is going to be obviously the plot of my cost function, because as I have the cost function here, the same code I'm using, the code that I have here, same code I'm using. So with a bit of changes, the values that I'm going to pass, they will change, the title will change, few things are going to be changed, the rest of the things are same. So there is nothing new. So if you still don't understand anything at any point of time, please ask question, please raise question. So figure size, then I'm defining this is going to be my first chart. Okay. Figure size up till this point, it's clear, I guess. My first chart, the subplot, what is the subplot is doing? It is telling this is the first plot. I need 2 plots, 1 row, 2 column. First plot is this. Then I'm defining the value for my limiting the value on the x-axis, which is going to be from -2 up till 2, and on the y-axis I'm just saying from 0.5 to 5.5 basically for the cost function. Then I'm giving it a title, which is the cost function, which is just the same as we had previously, giving it a font size. I'm telling on the x-axis, x label, I do have the x value. Then on the y label, I have the gx values uncommented out. Then I'm talking about the second plot, and I'm plotting it out basically. So I'm using scatter plot and plot as well. Now this point is important. Obviously, I'm passing the first parameter is my values, and the second one is my function, which is I am taking from here. If you can recall it, this is the function that I'm talking about. These are the points that I'm passing into this function. So I hope this is again clear to everyone. Cool. So I'm giving it a color blue, then the line width, then the alpha value, then I'm using a scatter plot. So scatter plot. So I'll share this code with you. If somebody don't have it, I'll share it with you. So please have it with you. Just hang on. Calling this function scatter. Yeah. Cool. So I'm passing a array list, because if I what is this list underscore x? What is this list underscore x? What does it have? Okay, it has the values of my new x basically. The value of new x are stored in it. How the value of a new x is changing over time, these values are stored in x list basically. So if I pass this list, I will get an error. So I need to pass it in an array. So that is what I am doing here. I'm passing it in an array, giving it a red color, and then trying to increase the size of the dots, because this is a scatter plot. I'm increasing the size. Then I'm trying to decrease the intensity by the alpha value. Then this is up till this is clear. Now the second one comes is the derivative chart basically. So how the derivative chart? Subplot 2, 2, 1, 2, 2. Two charts I have. This is the second chart that I want. Then I'm giving it a title. This is the slope of the cost function, a font size. Then I'm giving it an x label, which is obviously the values for x. And then a font size, which is 16. Then y label is the dg function, which is the derivative function. Then I'm giving it a grid. Then I'm pointing it out from -2. I need values from -2 up till 2. Then y label value I need from -6 to -8. and then I'm plotting the value. Again, DG value I'm passing in, and then I'm using the scatter plot, the derivative list I'm passing here. So let's comment it out and let's share it with you guys. Just hang on. Yeah, okay. So do you guys have the same code? Are we on the same page? Do you understand whatever is happening here? Can we move on? Can we plot this graph? Okay, great. So this is what happens. So as I said, my starting value is 0.5. It's starting from here, taking a very large step, and then it is moving. Starting from here, going up till this point, this, and reaching to the minimum value. As I said, there are two minimas, this one and this one. So yeah, and you can see on the other side how the slope is behaving. So you can see the slope is very high when we are at this particular point. It's very steep. And as we are approaching, no, sorry, wrong. My bad, guys. So this is how the slope is going. This is 0 at this particular point. It's starting from here. You can see it's taking a very huge jump from this to this, and then you can see it has lots of points at this particular point because it's flat. It's getting flat now when it's reached to the, because it's becoming 0. As you can see, the value is becoming 0. So do you guys follow this? What is happening in this particular chart? Can we move on? Any doubts anybody have? I guess this is pretty straightforward, and I guess this is clear to everyone. But if you have any questions, please ask. Is it clear to everyone? Please type yes or no. Great. Okay. Just hang on, guys. Hang on. Okay, great. Now, what I'm going to do, I'm going to change the value. It was 0.5. I'm going to make it minus 0.5. Let's see what happens. Can you see? Now it's starting from the negative value, which is minus 0.5. So in the same way, you can play around with the values, and then you can see, maybe you can say you want to start from this value minus, start it from minus 0.1. Let's see what happens then. And we have already seen the number of steps this is taking to reach to this point. Yeah, so when it is starting from this point, this is how it is coming downward, and this is how the slope is changing. It is going from this direction to this direction, and same way up here. Now, is this clear? So as I said, this graph has two minima and one maximum. Two local minimas are there and one maximum value. And also, when we go to the slope, it is intersecting 0 at 3 points. That means it is going to give me two times it is going to give me minimum value, and one time it is going to give me a maximum value as well, which is going to be somewhere here, I guess. So let's see. Now, if I start from 0, okay, no, let's make it from -1, then yeah, so it goes here this way. So that means this is the point for 0. Let's see which is the point for 0 where it's stuck. So if by mistake I start from 0, what happens then? My initial guess is 0. That means I'm already on the minimum value. No, can you see this? What is happening here, guys? Can you see this? If my x value is 0, then what happens here? What happens here, guys? Tell me. Yes, because the maximum value, absolutely. It is not going to move because now the derivative is 0. And we had this idea in our mind, we started with this idea that our derivative is going to change when we are on the top. Obviously we are going downwards, so the derivative is going to be very high at that particular point. It is going to be steep, and when we go downward it is going to decrease, and it is going to be 0 at the local minima. That was our understanding, but that is not always true. When you have 2 minima and 1 maxima, that is not going to be true. So that means if you want to use this gradient descent algorithm, what we have to do to solve this problem? Can somebody tell me, how can I solve this particular problem? Is there a way that I can solve this problem? Otherwise I would land it up here. I will end up here having a maximum value for the cost function. That is not good for my algorithm. So how can I solve this particular problem? Can somebody tell me, or should I tell? What should be the solution according to you? I want to know what should be the solution. How can we solve a problem, this sort of problem? Please unmute yourself and then answer. What do you think? Sunidhi, Sayyad, Ashima, Helena. I mean, you can give it a try. I mean, it doesn't have to be, perfect answer. I mean, you can try. I need responses, guys. Come on. What do you think? What we should do to encounter, if we encounter such sort of problem? What you will do? Unmute yourself and answer this question. Sayyad, Ashima, Sunidhi, I have to look for the number of steps and where is the local minima. So you are saying if you change the number of steps, that means the multiplier you are talking about, Ajay? If you change the multiplier, that is going to do something else.
Yeah.
That's what you.
Yeah,
Okay,
yeah.
so let's go and let's try to change the multiplier. Where is the multiplier parameter that I can?
It is 34, I guess. The last one.
The multiplier is 0.2, na?
Yeah.
It's already defined. So let's go. Let's take this multiplier. Let's supply a value. Which value you want to supply? Tell me which argument it is. Just hang on. Derivative, initial guess, then the multiplier. Okay, then I have the multiplier. I have it here. No. Initial guess. I'm not supplying it here now. So I will supply it. So what should be the multiplier value? We can try now. We can try, and then only we'll have the understanding. Otherwise, if we don't try out things, we will not have the understanding. This thing should be clear to you. This should be crystal clear to you in your mind.
If multiplier is 0.01, then number of steps will be increased.
Okay, 0.01 you are saying. Okay, let's try this. Okay, no effect.
No effect.
What else we can do? Let's keep it. Yeah, what it was. Anybody else? I need responses, guy. I need the input from you. Then only I'll proceed. I need responses from you. Please tell me. Sunidhi, Helena, Sayyad. Ajay gave his input. That's completely fine. If he can come up with something else, we can also try that out. But I need input from you. What do you think? I mean, what we should do? And if you don't have the input, that means you did not understand what we have covered. You don't have any idea what is going on here. That is what I will assume. No inputs. That means you did not understand whatever has been taught to you. You did not understand it. That's what I can assume, right? Okay, then I will also not answer this question. Leave it as it is. Leave it. Ajay, I will talk to you after the class and I will tell you what is the reason for it. How can we solve this sort of problem? I guess they are not interested to know. So
Yeah,
let's
yeah.
forget about
Okay,
that.
right. Hmm.
Yeah. Okay. Let's look at a new problem that we have now. Now the next function that I have here, it's a problem for divergence and overflow. So there was no divergence in this case. The function was just like this. So divergence is not, there was not a problem for divergence. We will create this function, which is x to the power 5 minus 2 x to the power 4 plus 2. And I'm creating my data point by using the linspace again, giving it a value from minus 2.5 and asking it to stop at this point, and I need 1000 points. And then I'm defining my function h of x, x to the power 5 minus 2 x to the power 4 plus 2. And then I'm taking the derivative, which is 5 x to the power 4 minus 8 x to the power 3. So if I run it, I have my data points basically. So now let's chart this function basically. No, this shouldn't be here. Yeah, it has to be. Okay. So what is happening in this chart? Basically nothing new. Nothing is new. I'm using the same old gradient descent, giving it the parameters and then running it out. I'm saying my initial guess is around the 0.2 and my maximum iteration is 71. Don't make them 71. Keep them, what was the initial values? Yeah, keep them 300 and let's see. Keep them 300 and then I'm using the figure size, the subplot, the title I'm giving to my chart, then the X label and the Y label. I'm plotting it out by using my third value that I've just created, passing it to my function, because this is my cost function, h of x3, which is this one that I have just created here. Then I'm giving it a color, which is blue color, then the line width, then the alpha value, and then I'm also using the scatter plot. I also need the point in the scatter plot. For now, let's do one thing. Let's not use scatter plot. Let's look at it without the scatter plot. So Ajay, do you have any doubts in it? I mean, it's pretty clear, I guess. Simply, I'm just passing the values and just trying to run the cell. Is it okay?
No doubt. It is
No doubt.
almost similar.
Yeah, it's same. I mean, the values are different, that's all.
Yeah.
So can you see I'm getting an error? What is the error? Overflow error. So what is the reason for the overflow error? Okay, let's look at the reason first of all. Let's reduce the maximum iteration. Let's keep them maybe keep them 50. And let's enable the points, because that's only when you'll be able to see this, what I'm talking about. Okay, so my point is starting from minus 0.2 and obviously my minima is going to be 0, right? I'm starting from this particular point and I want to reach to this particular point, and I want to reach to this particular point in 50 iterations. In 50 iteration, I want to reach to this particular point basically. So what is happening here? I'm able to reach to this particular point. Now let's do one thing. Let's try to increase the number of iteration, and let's see what happens. Let's make it maybe 70. And no figure size invalid plt.figure. What happened to it? Okay. Yeah. So can you see now it is going in this direction basically. It is going towards the, which is my cost, which is somewhere here it's 0. It's going to this direction. Now, can you see the step size is increasing as I'm moving downward? Ajay, can you see the step size is increasing as I'm moving downward? It is increasing.
It's a
Now let's try.
jumping. Yeah.
Yeah.
It's a jumping
Okay.
state is steps is more.
Right.
Earlier,
Okay. No.
earlier it was very close to.
No. It's not about the number of steps. The step size is increasing. As I'm increasing the number of steps, the step size is increasing. Okay, let me try
Yes.
to add some more steps to it. If I add one more step, you will notice. I'm also having the number of steps, which is 42. My local minima is this coming out to be. If I add one more, okay, let me reverse back first of all. What was the minima? 50. So my local minima was occurring at minus 0.34 when I had 50 iteration. If I reduce it, let's see what happens. If I keep it 30, then I'm getting closer to 0. Can you see? I'm getting closer to 0. My cost function, my local minima is occurring at this point. My cost function is around 1.98, which is obviously huge. And my step size is 31. Let's see if I decrease it more. Let's make it 20. Let's see what happens, because then only you'll be able to understand this thing. It's not affecting. It's the same. Do you know the reason why it's same? Can you see this curve? It's almost flat. It's almost flat here, and my slope is at 0. Can you see this, Ajay?
Nandesh, I have one question.
Uh-huh.
How many steps that we require to get the minimum cost?
That is what we are trying to look at now. That
Yeah.
is what we are trying to understand.
So
That
the
how
cost will be very nearer to 0. Then we can say that we have a minimum
absolutely,
cost. Yes.
absolutely. So that is what I'm trying to see now. How the
Mm-hmm.
cost is affecting when I'm decreasing the steps. This is the intuition I want to put in your mind, that how the step
Okay.
size is affecting it.
Yeah.
This is what I'm trying to do, related with
Mm-hmm.
the slow function, because only theory will not help. Obviously, when you see things in front of you, that's how you understand. Because when I was taught all these things, I did not understand them at the first place, because I was only
Yeah.
taught this is how it works, and yeah, you just have to keep that in mind, and I never understand them. But when I realized after some time that I can also do plotting, I can check the values, I can build my own algorithm, I can check the value, and I can see, I can break down what exactly happening behind the linear regression. Because the first day when we plotted the linear regression, we were not able to see these things, right? We were not able to see how the cost was affecting. We did not know that whether that is the optimal. Yes, we had the R score obviously, but we could not see these things, right? We could not see how the slope was affecting when I'm increasing. I did not have the control on the number of steps. I will talk about this. How can you do that? I will talk about this, but let's try to understand it from the scratch, from the basic, basically, that how it is affecting the cost. So now I've
And
decreased it.
one more question.
Mhm.
How do you set
Yeah,
that initial guess would be minus 0.2 or whatever? Initial guess,
that has
yeah,
that was
how you
the
can.
question. That was the question I supposed to answer at this particular point, which you are
Mm-hmm.
asking. But I guess
Mm-hmm.
nobody's interested to hear this, that why and how. Nobody's interested. So yeah,
Because
I'll answer
initial
this.
guess was generally randomly we are changing,
Absolutely. Absolutely.
but we don't know
That
the
is very
exact reason
important.
why we are changing the initial guess.
Right. That is very important. Now, initial
Yeah,
guess is the first step that we have to keep in our mind. Then the second thing comes that. But I guess they are not interested. I asked them for the input, and nobody's
yeah.
ready to give inputs now. So I guess
Mm-hmm.
that's very tough for somebody to give inputs. I'm not asking you to be, 100% accurate. Give me 100% accuracy. I'm just saying, give me some inputs. What do you think? What is coming in your mind, so that I
Mm-hmm.
can understand what is the state of mind you are in right now, and according to
Mm-hmm.
that I can tell you a few things. Because when I was told this thing, I did not get it at the first place, but my instructor also asked me, what did you understand? Please tell me, so that he can have the understanding what exactly is going on in his mind, what is the perception he's building. So I am also expecting the same thing from all of you to answer this question. Then only I'll be able to help you out. Now, if you will not tell me that, sir, I did not get it, obviously you will not get it at the first place. That it never happens to everyone. I mean, we don't get it at the first place. But if you will not answer this, ask me the questions, and if you will not tell me what exactly you are thinking about this thing, I mean, how can I help you? That is what I'm trying to say. So initial guess is very important key thing that we have to take in care. But I will not answer this until I get responses. Yeah. So I will tell you about this thing after the class. I will tell you about this, that why and how it is affecting. Okay, now, but let's look at the, the iteration, how the iteration are affecting. So now let's try to increase. Should we go down? I mean, maybe we could decrease them more. Let's see. It's not affecting. She's saying she don't know the question. Oh my God. What is happening in this class? I mean, Ajay, can you tell her the question? She's asking what is the question.
The question was, how can you set the initial guess, and what would be the steps so that we can get minimum cost?
As we see, when I'm putting the initial guess to be 0, it is giving me this cost. And do you think it's 0 at this particular point when I'm giving initial guess 0, which is the X value? So Sunidhi and Ashima, do you think is it the minimum cost? Okay, so so they are saying it's minimum cost. So can you check the value for what is the value for the cost?
It's
Is it
maximum.
minimum? It's maximum, right? But what exactly we are trying to achieve? We are trying to achieve the minimum cost.
Right.
I think they haven't looked at the previous things. Okay, let's break it down. I mean, let's put it again. So can you see Sunidhi and Ashima and Syed, when I'm changing my initial guess as to be 0.1, what is the cost I'm getting? So is it the minimum cost? Is it the minimum cost? Is it close to minimum? Yes. If I set it to minus 0.1, then what happens? I get this cost. Is it the minimum? Right now. So I've talked about this yesterday, that I have two minimas here, this one and this one, and I have one maxima. Over here, my slope is intersecting 0, 3 points. This point, and the other point here. Cost error is determined by derivative. Yeah, so I had three values for the cost basically. So if by chance your algorithm or you make your initial guess, because as I said, we have to make a guess. The first thing that we will be doing, we'll be making a guess. So if I make the guess to be 0, if I start the positions of X, if I inserted the value of X at 0, so I am getting the cost, which is the maximum cost. So my question was, how can I reduce this cost? What should I do to reduce this cost? That was the question. And you should pay more attention. Change the initial step. Yeah, so what should I change the initial step? Yeah, obviously we've changed the initial step, but what do you think? I mean, what do you think? Change the initial step? Yeah, that's closer. I mean, yeah. What about the others? What do you think? Syed, what do you think? What should we do? Sunidhi is saying change the initial step. So what should be the initial step, Sunidhi? anything more than 0. Okay, we should use the initial guess other than 0. Okay, right, right. Okay, so this is what I was asking for. So can you tell me what exactly you understand from these things that have been taught to you? What is happening here? What exactly we are trying to achieve? Can you tell me? You are absolutely right that we need to change the initial guess, but the question again arises, when I am using this gradient descent, how do I decide which value should I choose? So Helena pointed out very well that it should be other than 0. I could have any value. So maybe if I have 0.001, so let's see what happens. So it's other than 0, na Helena? It's not 0, it's 0.001. So is that right, Helena? It's not 0 now, it's 0.001. Maybe I can check 0.001 more. Still I'm getting the maximum value. What does that mean? What do you think, that there is a problem with the gradient descent? Is it the demerit of gradient descent? What do you think about this? So there is a problem. Yes, there is a problem. Absolutely, there is a problem. So how can we solve this problem basically? When we are applying the gradient descent, how can we solve a problem, this particular problem? How this problem can be solved? What should we do to solve this particular problem? Syed, what should we do to solve this particular problem? Tell me please, what should we do? I think we need to guess a range. Change the step size. Okay, so change the step size. So what should I keep the step size? The multiplier, right? What should I keep the step size? Sunidhi, can you tell me what should I keep the step size? The multiplier value? Okay, let's change it. Let's give it some value. Can I give it 0.5? 0.05? Okay, more than, yeah. Okay, make it 0.05. That will work? Okay, yeah, great. So does that affect anything? It does not. So what do we understand from it? I mean, what should we do if we face such sort of problem? What should we do? So there are different ways that we can look at this problem. There are different ways that this problem can be solved. The simplest way is going to be, I have to add randomness to my algorithm. What do I mean by randomness? Randomness, I have to try out different values of the initial guesses. That means I have to have something else, some other setup, or how a machine learning expert look at this problem? Before feeding anything into the algorithm, they design something, you can say another function they design in such a way which is going to pass in the initial guesses, which is going to make the initial guesses, and they are going to be random, and they are going to change those guesses and then do the comparison. And this problem can be solved by using stochastic gradient descent. That means it has more randomness. The gradient descent is another type of gradient descent which has more randomness to it. Because I'm not sure which value is going to give me the minima. I'm not sure for that, to be very honest. And when I'm adding randomness to it, I could might end up starting my point from 0 also. Yeah, that could also happen. So I might land up at the higher cost. I might not land up on the least cost, right? That could also happen. So that means I have to try multiple things. I have to try multiple initial guesses. One guess, two guesses, they are not going to work. I have to try multiple guesses. This problem, again, it was simple. In this case, we have both the values, both the minimas were minimum, global minimas, right? They have the same values exactly. What if you start from this point? I have that in slide, I guess. What if you have this sort of curve for the cost function? What if you have this sort of curve? So if you start from this point, or if you start from this point and you are only able to reach to the local minima, you will be never reaching at this point basically. If you start from this point, you'll be only reaching to this. From this, you'll be reaching up till here point, this point, which is the local minima, right? Then you won't be able to reach to this particular point. That means you have to start also from this point. That means you have to try multiple initial guesses. You might start from here and see where you landed up. You might start from here and see where you landed up. You might start from here and see where you landed up. You might start from here, then you landed up, and then you compare those values. So this is how you can tackle this problem. And obviously gradient descent has some disadvantages, but the main thing, the best thing about the gradient descent, it's very easy to understand. For a beginner, it's very easy to understand. It's very easy to relate to it. When we talk about more complex algorithm that we have, they are, more towards the complex side and the mathematical side, what exactly they are doing, how they are able to calculate it. So, but this is very easy for someone to start with, and then they can obviously shift towards more advanced. How we apply stochastic gradient descent, again, we have to code for it, and it is already coded. I will be not doing that. Then we have to use a multiple numbers, random numbers that we have to use, which will be act as which will pick from our list. We might have to use a for loop, which will act for our initial guesses. We might try different values. If else statement, how many if else statement you will write, Syed? How many if else statement you will write? That is the question now. How many if else statement you will write? Obviously you can use if else statement, that is never a problem, but how many if else statement you will write? That is the question that you have to answer to yourself. So what we have understand so far, that this algorithm is not best, and no algorithm that you will come across is going to be the best. There is always going to be something best which is there available, but it is something which is easy to understand, easy to relate, and it also have some disadvantages that we need to solve when we are applying it, and also we need to keep that in mind. So now we have this understanding in our mind that my initial guess is going to affect my cost. Before this, if I haven't shown you this thing, this would have never crossed your mind that this could happen. You would have always thought that my algorithm is always going to start from this point, always going to reach at this level. It's always going to start from this point, always going to reach to this level. Always going to start from this point, it's going to reach here. From this point, it's always going to reach here. You would have never thought of this idea that this could be also the case, that I might start from the maximum value, and at that point my slope is 0, so it is not going to show me any changes, right? So what we do basically for it, we code, you can use another algorithm for solving this particular problem, or you can code something like what we call that to be, there is a term which we call, I'm not able to recall it. So how does that work basically? No, that was for this, I guess. That was for the learning rate, not for the for initial guesses. For initial guesses, we have to add randomness to it. We have to check multiple values, because we are not sure which value is going to give me the least cost. So is it clear to everyone now? Is it clear to you, Ajay? Or do you still have that question? Is it clear to you?
Now fine, we'll see how to apply a stochastic algorithm.
Stochastic gradient descent. Yes, absolutely. Yeah, you can always look for that. But is it clear right now that why we are having this problem, and you have an idea in your mind that this problem can be solved and there is a way for it. You definitely know that,
Yes.
right? So we can, if we know that there is a problem that has to be solved and this is the way we can solve it, so always we can solve the problem. But when we are unaware of the problem, that there is a problem, then obviously we are never going to think about solving it. Right. So this is what I was trying to put forward, the point that I was trying to put forward from this slide. So then we will look at more complex function which I have here. So now we are trying to change the iteration. We are trying to work out with the iteration. So do you remember what exactly I did before this? Initial guesses and the iterations. Do you remember? Should I repeat it? Did you understand this particular piece of code that we have here? Everybody? Yes or no? Yes, great. Now, which function? Show the function. Which function, Sunidhi? DH? It's a derivative, na? Chain rule is applying here. Is it clear, Sunidhi? Can we move on? Is it clear? Okay. So let me increase the iteration. Let me take it to 70. So when I'm taking it to 70, can you see this cost is decreasing now? When it was it's getting into minus basically. So if I say it's 10, so the cost is not decreasing. It's 9 point something, and if I go close to 2, which is not minimum obviously, then if I make it what should I do? Yeah, keep it around 15. Let's see. So do you guys know what is this maximum iteration means? Do you guys know what exactly this maximum iteration doing? Sunidhi, Ashima, Sayyed, can you tell me what is this maximum iteration is doing? What is the purpose of it? Can you tell me, please? Unmute yourself and answer. No. I'm not asking. I'm asking what is the purpose of it? I mean, how it is working out. How it is working. What exactly it is doing. You are giving me the reasoning behind using the maximum iteration. But what I'm trying to ask is how it is working. It repeats the loop. Okay, yeah. It repeats the loop. Absolutely right. That means we are giving our loop to run for 15 times. It has to run. It has to go and update the value of the gradient descent, the value of the new. It is helping me at this particular point. Can you see max iter is used here now? Do you follow this, guys? Do you follow what I'm saying, or is it some other language to you? Get the iteration, repeat the loop. Absolutely. That means we are on the same page. Correct. Okay. So that means what I am thinking is what I'm trying to do is I'm thinking that I want to get to the minimum value just by using 15 iteration. I want to update the value of my x just 15 times only. Update the value of the gradient descent. Sorry, the gradient. What is the difference between other loops and max iteration? Other loops and max iteration. Okay, can somebody answer this question? What is the difference between other loops and max iteration? Am I not audible, guys? Am I not audible? Hello? Hello? Ashima, I guess you have an internet problem. So Neha, there is no difference. We are just using it as a attribute, or you say parameter, for my range function. I'm telling it to run this many times. I'm making it dynamic. Otherwise, I have to come here and write it down that I need to run it 10 times. I have assigned it a variable max iter, that when I update the value of the max iter, it automatically gets updated. I'm trying to make it dynamic, not static, because we always need dynamic functions when we are applying ML. We are not going to go back to our code and update it every time. I need some variable with wherein I can pass some value and I can get my output. So I guess the reasoning is clear in everyone's mind that I am trying to achieve the minimum cost in 15 iteration. That is not happening. Let's make it 30. No, it's not even changing. It's 9.988. It's not changing. Let's add more iteration to it. 50 maybe. Yeah, it started to change. Can you see it started to change? It's becoming now 1.09. It's started to change. Now let's do something more. Okay, let's make it 60 maybe. 60. Yeah, it's getting closer to the minima value, which is 1.69. Okay, let's increase the loops again. Can you see it just overshoot from 1.6? Before that it was 1.6 now it is minus 3.81 the cost. Okay, if I make it 60, can you see it's 1.6? Okay, let's add loop slowly. Let's make it 65. How does it affect? Okay. Now it's becoming 34, minus 34. If I decrease them more, okay, let's make it 62. It's 1.4. If I increase one step now, then let's see what happens. 1.4 to 1.07. Okay, let's increase one more step. I hope this is making sense to you all. That's what I can only hope for. So yeah, now it is getting closer. And can you see the jump it took from 1.04 to 0.39? If I go back and increase it by 1, see, now see, notice the jump. It's minus 3.4. We checked each and every loop and we were not able to go to 0. It is obviously decreasing. Let's add some more values to it. Let's make it 67. Can you see it's minus 56? We don't have that value up here. It's becoming minus 60, minus 56. If I increase it more, maybe make it 70. Minus 3.4. It's coming back now again. I mean, in 72. Okay, let's make it 71. Okay, let's see then. Minus 2. Okay, let's add more to it. Maybe 3. Can you see this overflow error? What do you mean by overflow? The result too large. Okay, so I'll explain it to you. What does it means? So basically what is happening here, when I am increasing the loop, instead of reaching to particular point and stopping the iteration, just look at the cost, just look at the slope also. Okay, can we can have a negative value of the cost function. Yeah, it depends on the function now. See, this is the function I have, it has the negative value. So the point that I'm trying to make is, listen to the point, then you can ask the question, Ajay. Okay.
Okay.
So this is my function. Okay, so I can have any type of cost function. It is not fixed, that it is not standard written in some book that this is going to be the type of a function. And this is only that the thing that we are talking about, it's in single variable. I'm not using multiple variable. I haven't used multiple variables till now. I'm using single variable, only x value. I haven't used multiple variables. So what is happening when it says overflow? That means when I'm increasing the loop, it is overshooting. That means it is going towards negative infinity. So you can imagine that is going to be too large for my computer to handle. So that is why it is giving me the error or overflow. And that is again the problem with the iteration, the maximum iteration variable that we have. That is the problem we have with the maximum iteration, and that is why I say there is a problem for overflow and divergence. It is diverging, it is not reaching to zero, it is going beyond zero, it is diverging. When I keep it like increase and decrease the loop, sometimes it's minus 55, sometimes it's 2.1, sometimes it's minus 3.4. We all have seen those values. So it is diverging, it is not reaching to that particular point. If I go to the positive side, if I take it here, then you will see different things also. You will keep on increasing also. Let's take it to the other side. Let's make our initial guess to be this and then run it. Yeah, so it's going in this direction. Let's make it maybe more. Let's make them 100. So yeah, it's getting closer to it. But if I want my value to, we know that it is going to reach to this point, right? And yeah, it's close to zero. It is going to stop at this particular point. So let's see if it stops or not. Let's make it 150. Let's see what happens. It is reaching to this point. If I add more values, then what happens? Now it is not moving. Let's see if I add more iteration, what happens? Not happening, nothing is happening. It's stuck at that point, basically. It's stuck. If I add more, then it will also not move. Let's see, let's make it 90. So it is not going to move because it is at the minimum cost. And as you see, the slope is 0. It is not going to move. So that means once I reach to my minimum cost, and at that point slope has to be 0, and that is when the iteration will stop. That is when, I mean, my cost function will not change. We have achieved 0. Yeah, you can say that is close to minus, it's negative. That's the cost function value. We cannot achieve 0. Cost function cannot be 0. Can you see it's not intersecting at 0? The value of the cost function, it's never intersected 0. That means we cannot have this value. We have to tweak the value for the iteration, then might be we are able to achieve it. If I make it maybe 150, let's see what I get. I get cos to minus this. Let's make it 100, then see. So the thing that I am doing, the thing that I am trying to do, changing the parameter and checking my values, how they are affecting, it is called as hyperparameter tuning. And that is most of the time, that is what the data science, the ML engineer is going to do. creating an algorithm, as I said I have said it multiple times, I guess, that creating an algorithm is not a big deal, but optimizing it and changing the hyperparameter, getting more and more accuracy, that is the challenge that we have to face. And that is when the most of the time gets spent over. So that means, okay, let me make it 120. Let's see if I am able to reach 120. It's again shooting somewhere. Let's see, let's make it 110. Again it is, let's make it 105. Let's see what happens at that point then. Okay, yeah, we are getting closer. Let's make it 3. So yes, we are getting closer to the 0.36. It's closer to 0. If I make it 2, let's see what happens. No, 0.3 is better, I guess. Or 0. Let's try 0.4. What happens if I try 0.4? It's going in a negative direction. So 0.3 is, I mean, it's good at this particular point. Okay, now we have looked at two parameters that I can have a different cost function when I change the value of my initial guess. That's the one parameter that I have. Then I have second parameter, which is the maximum iteration. I also have other parameters, which is the what we have. What is the other parameter we have? Tell me. What is the other parameter that I have here? Yeah, that is learning rate. Yeah, so we'll also talk about that. Yeah. So Ajay, what was your question? Please ask that question. Do you still have that question or not?
The question is, can we have negative value in the cost function so that we
Yes.
could get minimum error value?
Yes, we could have. So it depends on the cost function. Now you can see this is my cost function. This is how it is plotted.
Yeah,
So it could be of any shape. I could have more complex cost function.
just we have to look for the global minima where it
Global minima.
stands. Yeah, global minima.
Global minima, I guess this is going to be the global minima.
Yeah, this
But
is
no,
yeah.
not global minima, because in this case, if I say this function, the cost function, it is not stopping at this point. Nah? This continues. This continues. Now I don't know where it is going to stop. I have plotted up till this point. So it is overshooting. It is going the negative value. It is giving to me as a minus infinity. That is what my algorithm is not able to find. But then again, I have to do some adjustments and stick with some values. Maybe I'll go with this value, which is a minus 0.36, which is close to 0. If I want negative value, so obviously I can have negative values as well. Then it will have some negative impacts as well. Right?
Okay.
Right, obviously. So this is called hyperparameter tuning, and that is what we try to do. You might have heard of this word a lot. Some people in the videos, YouTube videos, might be on the articles, people talk about this a lot. Hyperparameter tuning. So this is what hyperparameter tuning is. We are trying to change the parameter and trying to see what is the difference. Otherwise, before we discussed about this, there was no difference, right? We thought that we'll insert the value in the cost function, we'll design a gradient descent, we'll insert the value, and yeah, we'll be getting good cost. I mean, good accuracy. It will make a good accuracy. That's what we thought. But I guess it's not that easy. I mean, there are other parameters that has to be taken into consideration, lots of other parameters. One of them is a learning rate, which I have here. So I will also talk about the learning rate, how does that affect. But before we do that, let's take a break. I guess that was a lot for you to digest, so let's take a break if that is okay with everyone. And if you have any questions, you can ask, and then we can take a break, and then we'll look into a few other things, the tuples and learning rate. How does the learning rate affect my algorithm? That's okay with everyone if we can take a break. Okay, do you have any questions before that? Any questions? I want the code, stochastic gradient descent. So I have to look for the code actually, or maybe I have to code it myself because I don't have it right now with me. But you will definitely find it, stochastic gradient descent. First of all, we
How
have
can
to
you
understand how stochastic gradient descent, huh?
see? Keeping change the value of maximum iteration or whatever the parameters are there, and it
Mm-hmm.
will take more time to get the correct value or get the minimum error.
Exactly. Absolutely
So
right. Yeah.
that's why we
Yeah.
will look for a stochastic gradient descent, that automatically it will
Absolutely.
choose the best one.
Absolutely. But
Yes.
actually, when I talk about applying the algorithm, this is for your understanding, first of all. This is for your understanding what is happening behind the scenes. If you want, you can code your own stochastic gradient descent. That's not a big deal. It will take some time, but you will be able to code it. But we have that already inbuilt. If you go and look for the library, it is there.
Okay.
Stochastic gradient descent uh, in Python, if I say, it is there already there. Because gradient descent in Python, I don't want this. It's already there. So I will also talk about this. How does this affect basically? Yeah,
Okay.
it's already there. It's written there already. The loss function we have there. Then obviously a few more things will come into picture that we have to take in account. You can see argument parsing is happening. I mean, epochs we are taking into account. Epochs is again the same thing. You might heard this a word a lot. Epochs.
Iteration.
That is
Iteration.
the iteration. Somebody is not aware of that. That is the iteration. So yeah, that's how we are able to do this. So this curve, I plotted this curve basically, the loss and not the loss with respect to loss. I have it with something else. So I will show you that how the gamma value changes. How does that affect? That is my learning rate. How does the learning rate affect my algorithm in this section basically? So yeah, at the end of the lecture, you will have the code, Ajay. That's not a problem.
Okay. Okay.
But my intuition, my motive was to give you the intuition that what does happen in the behind the scenes when we code something, so that if you want to build something of your own, you want to build your own algorithm, I mean obviously you can, but I would always suggest that use the algorithm which are already there, because they have done lots of hyperparameter tuning already, which is going to take you a lot of time, because these are not only the things that you have to keep in mind. There are multiple things, multiple challenges will come up when you solve one problem, then there will other problem that will come up.
Yes.
Yeah, okay.
Okay.
Yeah, okay guys, so let's take a break and for 15 minutes, then we'll come back. It's 20, so let's take a break up till 35, then we'll come back and then we'll see how the learning rate affects my algorithm. Okay. Okay. Okay, guys, you there? Can we start? Can we start, guys? Everybody's in? Okay, so somebody was asking me about the stochastic gradient descent. So it's already there in the scikit-learn library. You don't need to code it from scratch. If you want to, it's already coded by, it's in this blog article. If you'd like, you can go and read it, but I would say it's going to be a little challenging for you to read this. So I would say not to do that, but if you would love to do that, I mean, yeah, you're welcome. I've shared the link for this. And also, if you want to read the documentation of stochastic gradient descent, so yeah, you can refer to this thing also. So now we have looked at two parameters. One is the initial guess, how it is going to affect my cost function, if how the initial guess, and we have also looked at the iteration, basically iteration. So how can we control the iteration in a way? So we can control the iteration. How can we control the iteration? Yeah, that is going to be the question, obviously, that's supposed to be asked. There are multiple ways that you can have a control over the iteration again, with which you are able to receive the minimum value so that you don't overshoot. So I'll cover it when we will talk about the gradient, this learning rate. But before that, let's talk about tuple, Python tuples, or somebody say it's tuple. Let's talk about them. What exactly tuple are? How can you construct your own tuple? So okay, let's leave it. Yeah. Okay. So basically, you can construct tuple is again a data type that you have in Python. You can construct a tuple by passing in a round brackets, pass in some values 1, 2, 3, 4. Create the tuple. If you go and check the type, it's going to give you the type of tuple. If you want to access any value of a tuple, you can do the same indexing that we have learned. 0th index, first index, third index. So this is tuple. We can also design a tuple in also without using the round brackets. That is also possible. How can we do that? So I'll say tup underscore 1 and I'll assign it to maybe what should be the values. So there is no restrictions on what this should be the data type inside it. It could be integer, it could be character, it could be floating point numbers as well. So there is no restrictions on that. You can have any data type into it. So yes, I guess, yeah. So let me show you how can you construct a tuple without using the round bracket. A, B, then I have 1, 2. Now let me try to access it. Let me try to check the type to show you that it is a type of tuple. Okay, my bad. So it's a type of tuple. So this thing that I'm doing here, it's called as tuple packing, basically. I'm passing in some values and then packing them into a tuple, basically. So can I create a tuple with single argument? So let's see. Can I create a tuple with only one variable onto that? If I say t is equal to this, and then I check the type, it's not going to be a tuple. If I use the round brackets also, pass 1, check the type of t, it's not going to be possible. But if you want to do it, how should you do that? That is important. So let's see. I have to pass in a comma, extra comma, when I am creating a tuple. Now, if I do this, so you can see now it's telling me it's a type of tuple. I can do that inside the round brackets as well. It's a tuple. So tuple packing is done. Oh, okay. What else should be covered? Yeah, beacon. Okay. Single loop. Yeah, we can also do the iteration on the tuple. I can say for I in T, print I. So it is going to show me the values of I. Sorry, the tuple. What is T? Let me check first of all. What is T? Yeah, there is only single value into it. If I have multiple values assigned to it, then I'm able to print the multiple values. Okay, hang on. So I can unpack the tuple as well. So is there any other way to do it? So let's look at the code that I've created here. What I'm doing here, first of all, I'm creating a tuple. I'm creating a tuple which is a breakfast, and I'm assigning it some variable which is bacon, eggs, and avocado. And it's a very good breakfast. You can also have it. And I am also creating another tuple which is for the numbers, basically 13, 4, 9, 26, and 17. Now how can I access the value? So I can also use print statement. I love breakfast. I am accessing the second zeroth index, which is this. So if I go and comment this out, no. Yeah. So you can see I love beacon. If I change it to 1, maybe, then I will have this eggs. If I change it to this, then yes, I am able to get it. Now let's see what else I can do with tuple. Yeah. So I am saying my hotel number is, and then if I don't use the str, then what is this unlucky number 1 is going to give me? What is this unlucky number 1? What should be the output of this value? Please tell me. Are you guys listening that I'm asking a question? What is going to be the output? Beacon, unlucky number. What is unlucky number? This tuple I'm talking about, na? Syed, please focus. 1, okay. Sunidhi, what happened? From where the indexing starts? Indexing starts from 1, or does it start from 0? Yes, it starts from 0. Absolutely. Unlucky number 1. Yes, that's right. I'm going to get 4 here. If I use str, if I don't use str, sorry. So what will happen? Let's see. Let's remove this. So do you think it will work if I don't use str? Will it give me the output? Let's see. It's not going to give me the output. Can you see the reason? It's a type error. It's telling me can only concatenate string, not integer. So what does this mean? Okay, I get it. So let's say I have a string which is hello, and I want to concatenate this string with a number 5. Can I do that? I cannot do that. But if I really want to do it, I have to convert this into a string, basically. That is the only way I'm able to do that. So I hope this is clear. Now if I go back and convert it into str, then run it, it will work absolutely fine. So my hotel has 4th floor. Hotel has a number 4th floor or something like that. Now what am I doing here? So I am creating a tuple. As I said, you can pass different type of data into the tuple, and that's what you do. I mean, you can pass different types of data into a tuple, then you can access them. Most of the cases, this is what you will be using for. And one more thing about tuple is tuples are immutable. Do you remember I told you the same thing about something else as well, that this data type is immutable? Which was that? I said the same thing about another data type, that this data type is immutable. Do you remember which data type that was or not?
String is an immutable
Yes, exactly.
type.
So string data type is immutable. So I can, the same thing goes for the tuple. Tuples are also immutable. Exactly. That means you cannot change the value of a tuple. If I want to change 13 to maybe 14, I am not able to do that. But obviously, you're not going to take my word for it. Let me show you this. If I run it, let me check. Yeah, it's printed. Okay. Now I want to change number one. Can I do that? If I want to access number one, how can I do that? I have to pass it 0, and then I will assign it to, maybe I want to change to 14. Can I do that? So it will tell me tuple object does not support item assignment. That means they are immutable. You cannot change their value. That means you can use them in a place where you don't want anybody to change the value. You want the fixed value inside it. Maybe you want to store a password or anything else. You want to store the address. You don't want to update the address. You just want to keep it as it is. Or you can store multiple data, I mean, different things into it. So I'm storing my address here, one infinite loop, and Cupertino 5095. So what I'm trying to do, tuple with single value. So I've talked about this already, that I can have a tuple with single value. That is possible, but I have to use the comma after that. It will give me tuple. Now I'm saying, so this is what is this called? This is called tuple unpacking. So what is happening here? Let's try to see what is breakfast. Breakfast has 3 values inside, is bacon, eggs, and avocado. So this was tuple packing. This is tuple unpacking, right? So that means I am assigning the value bacon to this main, side to eggs, then greens are avocado. If I go run it and then run the code, this code, which is the main course is main, so it will tell me main course is bacon. Then if I go and print, maybe that what should I print? Side meal is, I can pass side into it, so it'll tell me that side meals are eggs. I can also say that my usual greens, the usual greens that I have in my breakfast, my usual greens for the breakfast. So then I'll assign it to greens. So have we seen this? Have we encountered this tuple unpacking in our code? Can somebody tell me, have we seen this tuple unpacking? We have one variable and we are assigning a one variable's value to 3 variables. Okay, where was it? Sunidhi, can you tell me? Where was it on the code? Where exactly we have seen this? Okay, so without wasting any more time, I'll show it to you. So this point. So this point also. This point we are doing tuple packing. 3 variables we are putting into 1 variable, returning them. Over here we are doing a tuple unpacking. We are extracting values from it. 3 values, which are these. Local minima is the new x list is x list, slope list is derivative list. This is tuple packing, this is tuple unpacking. Do you follow this? Whatever I'm trying to show you, do you follow this? How this thing is happening? Please type yes or no, guys. Great. Now I guess we have a more understanding of this function, that how this is working. And okay, let me come back to this point, then I'll add few more points on the previous thing that we've talked about. Few more points I'll add on. So now what I'm trying to do here, I'm assigning the value. Can you see this initial guesses to this? This is my gradient descent function. I am assigning it the value as into a tuple to showcase that yes, it is possible. Now if I want to access two values, I am saying the local minima is, this is going to be the first value, the local minima. If you don't get it, please tell me the local minima, how I get this local minima as 1.59. If you don't get it, please let me know. Do you get this or not? What I am doing here, let me go back. So this is my gradient descent. What is the output of this gradient descent? The output of the gradient descent are 3 variables which are stored in a tuple, as I said, because this is tuple unpacking. This is tuple unpacking. So the first is the first index. What is at the first index of this very tuple? The first index is the local minima. What is the second? It's the list of the all the values of x. What is the third? It is the value of the derivative. Do you follow this, guys? Great. Yeah, so this is what I get, the cost of the last x, the cost, then number of steps. How can I check the number of steps? I can just take the length of the second list, which has all my values of x. I can just check the list because it will have the number of values, how many times it will run. So the second list that I have, the second element of the tuple x list. So that is why I'm using the length function. So is it clear about the tuple packing, unpacking, how it is working in my function that I've created for the gradient descent? If it is clear, so then I would like to add one more point that some of you might be thinking, or I don't know why, where are you thinking or not. So I can have some sort of, while loop created for the maximum iteration. What should be my maximum iteration? Or maybe, that if my value reaches to this particular point, then this should happen. Then you have to think again, if this question comes in your mind, that for the while loop we can encounter a lot of problem if we are not sure that what is going to happen if this happens, because the while loop is going to give you continuous value and your computer might freeze, it might get stuck. as I said before, if I put a condition which is never going to be satisfied, that means my loop is going to run continuously. And for that, I have to be sure that what is going to be the effect. That means I need to have more information about the other thing that is going to affect my algorithm. So keep that in mind if this question comes in your mind, that can I use while loop for controlling this parameter? Okay, so let's move to the next part. We have only half an hour, so let's see how much we can cover. So I'll go to this notebook without wasting any more time. So I'll just have the learning rate. I'll just copy paste it and I'll just try to explain it to you. If you have any questions, guys, please ask right away. So again, this chunk of code that I have here for the learning rate, I will explain it to you each and every line. So basically, what is learning rate? Do anybody know what is learning rate? Because this is the first time that I am discussing about the learning rate. I haven't talked about this before. But still, if somebody knows it, I mean, that's good here. If somebody knows it already. Multiplier we use. Absolutely, Sunidhi. Oh, I told it. Oh, okay. Okay, I didn't know that I told it. Okay. I thought it was in some other class. Okay, okay. Okay, great. Yeah. So maybe I have told you about so how does the multiplier affect my algorithm? What do you think? I mean, how does it affects? What is the effect of the multiplier? Let's go back to our function, the gradient descent function, and let's look at what is exactly this multiplier is doing. Yes, yes, yes. You're right, Sunidhi. So tell me, how does it affect my function? What is the effect of the multiplier? How it is going to affect? Can somebody answer this? Step size. It is going to, okay. Yeah, it is going to talk about the step size, obviously. But how? How? If I increase the multiplier, the step size is going to increase. Okay, okay, Sunidhi. Then again, you got a new term, which is step size. Yeah, we've discussed about it a bit. So how does the step size get affected? What are the dependent variable, or the step size is dependent on what? Please tell me. Step size is dependent on what? Okay, leave that. What is step size? Great, yeah. Gradient and new position. Absolutely, absolutely. Not right, but yeah, you can say that. So I get a new position based on the step size and based on the multiplier, that means, and the gradient. You can see this is my new position. So my new position is dependent on the previous position and the learning rate, which is the multiplier, and the gradient, that is the slope. So that means my new position is dependent on these two variables, because they are going to change. Obviously it is going to change, but we don't have control on it. But yes, we can manipulate them. Maybe we can increase the multiplier, or maybe we can but we cannot increase the slope. That is also again not in our control. The slope is going to be in a control of a function. It could have different slope at different points. I mean, if I go and check back in this case, like as we see, the slope is very high at these points, and we are getting closer and closer, so it is decreasing. So this is the step size, right? We were talking about, Sunidhi, you were talking about the step size, is that right? That step size starts from here, then it is taking a huge size. And why? What is the reason for it? Because if I'm not wrong, then in this case, if I go back and I have set the multiplier equal to 0.1, which is not a huge number, which is very small. That means the multiplier is very small. But then what is the thing which is affecting my step size? The second thing is the gradient. The gradient is very high. You can see it is very steep at this particular point. And that is why if a higher value get multiplied to a smaller value, what is going to result? What is this going to give you in result? If a higher value, let's say, let's have a calculator. If somebody does not follow this, let's have a calculator. And let's see, how does it affect? Okay, let's go back. Let's make it standard. Okay, let's say what is my gradient at this point? I mean, yeah, the slope at this point is close to 5.5 now. So let's multiply 5.5 with my multiplier. What is the multiplier? It's 0.1, I guess, if I'm not wrong. What is it? What is it? What is it? Oh, no. Where do I have it? Yeah, it's 0.1. So let's see, how does it affect? Oh, come on, yeah. So this is the value. Okay, let's try to increase this multiplier. Let's see how it affects if you don't follow this. So I'm keeping 5.5 the same. Let's try to decrease the value. Let's make it 0.001. I guess that's very evident, but yeah, let's see. So is it increasing when I am decreasing the size? Is it decreasing or increasing? It's decreasing, right? If I make it, the slope is same, the gradient is same. If I make it 0.2, maybe it was 0.1 before, does it increase? Okay, let me show it again. 5.5 into 0.1. So this is the one I have, which is when is it's 0.1, which is very small. And let's say I say 0.2. Can you see? So when I increase my multiplier, that is my learning rate, my step size is going to increase. Or the other way around is going to be when I have a small step size, but if I have a huge gradient descent, I mean huge gradient, that is huge slope, the slope is very high. If I have it 6.5, so obviously the number is going to be very large. So that means they do affect each other. Is that right? That they do affect each other. So if the one value, absolutely. It was very abstract idea, and I guess this was clear. So we've talked about the gradient descent. Gradient descent, we cannot manipulate the gradient descent, right? That is not under our control. Or is it? Is it the gradient descent under our control? Can we change the gradient descent? Can we change the value for the gradient descent? Can somebody answer this? Right? That's not under control. So that means that parameter, we cannot change that parameter. At least for now, we can assume that we cannot change that parameter. But can we change the multiplier and see how does it affect my cost function? Is it possible? Can I do that? Let me put the question again. Can I change the multiplier and check if it affects my cost function or not? How does it affect it? When I decrease the multiplier, how does it affect my cost function? Right? So this graph that we were looking at here on this article, which was for something else also, it was telling me about the loss. What was it telling me? It was telling me about the loss and the epochs, how the loss and the epochs affect. If I, this is the loss function, basically the loss up here, it's increasing, and these are the epochs. How is it affecting? That means when I'm increasing, in this particular case, I don't know what data he's using. In this case, he's doing when he's, what is epochs? Epochs are iterations that we have seen. Iteration, yes, the number of iteration. You will hear this word a lot. People use a lot of fancy words, Sunidhi. On the internet, they use a lot of fancy word just to sound cool, and obviously they don't want you to understand all these things. they want to look at it's very tough, nobody can understand. So yeah, as for the maximum iteration, they are using epochs. That's what they will use all the time. I mean, so what they are trying to tell me is that if I increase the number of epochs, if I run my algorithm multiple times, how does that affect? And we have already seen it. I haven't drawn this thing, but yeah, we haven't drawn in such a way with epochs versus the loss, but yeah, we have seen how does it affects in this example. In this example, when I was changing the multiplier, what was it? Where is it? Yeah, in this example, we have seen it, right? In this example, we have seen it. Which one? Yeah, we have seen in this one now. We have seen in this case that how does the maximum iteration affects my loss. That's right. Now that was another parameter. Now what we are going to do, we are going to look at how does my, I mean, how does my what do you call it? Oh, how does my learning rate, as we say, or the multiplier affect the lost function? And I will show it by plotting it. And this sort of graph we might see. This sort of graph, not exactly, but yeah, this sort of. So what is happening here? I am calling my gradient descent function, nothing new. It's the same. Let's keep the iteration, maybe let's keep them 100, not a huge number. Let's keep them 100 for now. And then I will break down this code for you. Okay, learning rate. Just hang on. Okay, yeah, it was the first example. All right. So what I'm doing here, what was the learning rate? What was the multiplier before? It was 0.1, I guess. Let me check. It was yeah, no, it was 0.2. So I'm not changing it. I am just using the last value that I had. Okay. If it is getting too complicated, please ask questions. Is it getting complicated or is it simple? I'm just trying to make it as simple as possible from my end, because I'm not getting any responses, so I feel like it's getting complicated. Is it getting complicated or is it understandable? Can you understand this thing? No, it's simple, right? It's straightforward and simple to everyone. Straightforward and simple for everyone, I guess. Great, you guys following this. So what I am passing, what is happening here, this is nothing alien to you, I guess we all are familiar with this. I'm just passing the gradient value, the initial guess. I am just telling the initial guess is going to be 1.9 basically. So I am using the same values again, the same value of gx that I have defined previously. What is gx? If you can, what is gx? Yeah, these value which I have in between -2 up till to 1000 value, that is what I'm using. And this gradient function I'm using, which is dg. So don't get confused with this. This is very straightforward, but if you still get confused, please ask questions. So initial guess I'm making, I'm starting from this point, maybe my slope was this, and I'm starting from this one. It's going to give me the same function. Remember, it's going to give me the same function. I'm starting from this point. Where is my cost function? Is 1 point, maybe it's somewhere cost function, no, x value, no. So x value close to this point. I'm starting from this point, guys. I hope it is relatable to you what I'm trying to do here. I want to go to this point. This is my least cost now. So yeah. Okay. Multiplier is clear. Maximum iteration, I'm giving it to 100. Nothing new is happening here. Nothing new. I'm just giving the name. Nothing new. You can check. Subplot, I'm telling. Limits, I'm passing. I'm giving it a title. X label, Y label, GX, it's a GX, then I'm telling it's a plot. What are the things that I want to plot? I want to plot the value for X2, which was my second function that I've created, X raised to power 4, something was, yeah, then I'm passing it to my gradient or the derivative. Then I have a color which is blue, then line width I'm using, then scatter I'm using. Scatter, what are the values of scatter? Scatter has X list, which is the values for all the values of the new X, basically. How the X is getting updated. I want to check that now, how that affects my gradient. That's what we've been doing. And I'm converting this to array. If I use it without array, if somebody is curious, so yeah, let's try this without array. So this is for the size of it, and on the other side I'm using the X value and the derivative list. Nothing new is happening here, guys. Is it clear to everyone? Is it clear? Okay, great. Let me run the cell. It's gonna give me an error because I need to pass in the numpy array. Otherwise it will give me an error if you will pass a list. Now this is how it is working out. Can you see? And can you see the step size? I mean, and how many iteration it's doing? It's doing in 14 iteration. I mean, 14 step it is taking. 14 step it is able to reach that point, right? I guess you follow this. It is able to reach that point in 14 step. Now let's do something else. Let's change the iteration. Let's make it maybe 200. Let's see how does that affect. No effect, because it has reached to this point. Obviously the iterations are not going to work. If I pass it 500 also, nothing is going to change, because the slope is what is the slope here? The slope is already 0, so it is not going to go beyond this. It's 0 already. Now few things come into picture now. Let's see this chunk of code that I have here. So yeah, I'll break it down again and try to make you understand what is happening here. Okay, if you don't get it, I mean, just tell me, just give me a heads up. Okay, yeah. So what is this code? Okay, this is nothing new. So first of all, I'm giving n. What is n? This is the value I'm passing for my iteration, because I don't want to pass 100 again and again. I am okay. Let me tell you what is happening here. Okay, let me comment this out first of all. Let me draw for one only. Low gamma, yeah, I need for low gamma only. Mid learning low gamma. Yes. Okay, that should work, I guess. Okay, so what I am doing here, let's see. I'm running the gradient descent 3 times with different parameters. So we'll see what exactly I am doing. The n value is the multiplier. Now low gamma I'm giving. That means low gamma is basically my learning rate. Some people call it gamma, some people call it learning rate, some people call it alpha. So this is my learning rate. I am giving a very lower value. Initially I was using 0.01. Now I'm using 0.0005. So if I multiply 0.00 yeah 5 with 5.5, right? I had 5.5. So can you see? This is the gradient I get. I mean, this is the output. I mean, the step size is going to be very small. The step size is going to be very small. As we have seen, the step size was very huge now in this case, because the gamma value or the learning rate was 0.2. It was huge. So that is what I'm trying to reduce. If I want to decrease the step size, because I cannot mess with the slope, the gradient, as you say, but I can always change the learning rate or the multiplier. So I am going to change the multiplier. Do you guys follow this? Great. So the output that I'm going to get from it, I'm going to store that into low gamma. And again, what is this low gamma? It's a tuple. As you know, the output for the gradient descent, it's a tuple. It has 3 items. Do you remember that? I've shown you already. It's a tuple. It has 3 values. Is that right or not? It has 3 values. Again and again, I'm saying the same thing. So I will be using it. Okay. So what am I doing here? What am I doing? Okay, let's see. So I've stored it in a tuple, whatever the output is. Then what I am going to draw a figure and plotting the reduced in the cost of each iteration. How the cost get reduced with the iteration. Then I'm giving the value from 0 up till n for the x-axis, y from 0 to 50. I'm giving the label as title, effect of the learning rate, and y label and so on. Now, what should be the value? What values I want on the y-axis? I need to convert the gamma. So what is the first index of this low gamma? What is the first index? What value I have on the first index? So I have this list, this x underscore list. What does this list have? This list has all the values for my position of new x. So I am storing it on. I'm using it on the y-axis basically. Low values. Then what I have on the x-axis, I'm using the iteration basically. I'm using the iteration as a list basically. How does it affect? How the values get affected with the iteration? This is what I am trying to plot. Okay, now this is my plot. So what do I have in the plot? I have the iteration list and the low gamma value, the function with the low gamma value. Giving it a light green color, the line width, and I'm giving a scatter plot in which iteration list is there and g values are there. Okay, let's draw it without wasting any more time. Let's draw it and let's see what happens. Can you see this? So this tells me the cost with number of iteration, and I guess this is what we were looking at. Cost or loss with respect to epochs. This was the gradient descent was telling me now that how it get affected. So might be if you go back to this code, you might understand few things. So we can see how this is the cost. The cost was very huge when it started. It was close to 50. Then it keeps on increasing as the number of iteration increased. In this case, as the number of iteration increased in this particular case, and eventually it reached to close to zero, not zero. Now let's have let's create another list which will have yeah, of course there was a challenge for you guys to have a mid gamma value which was 0.1, but I guess we don't have that much time. So yeah, let me talk about this, what exactly I'm doing now. Same thing I'm doing, just one thing is changed, which is this multiplier, the learning rate. I have reduced it. It was very small. I have increased it basically. Increase the learning rate. Do you guys follow this? How it increased? So this is the value I was getting when I was using 0.005 multiplying it with 5.5. So let's see what I get when I multiply 5.5, sorry, 5.5 into 0.001. What should I get? So this is not a that bad number. I mean, the step size is good. I mean, so this is a mid gamma value I'm using. Now let me go back to my plot, and yeah, I'm plotting the mid learning rate. I'm giving it a different color, steel blue color. Can you see this? How does it affect the cost? How the cost is getting down? What is the difference between these two? Look at the graph, think, put this in your mind and just imagine what is happening here. Maybe when you see more values, then you might understand what is happening. Now I'm using high gamma value, which is 0.002 again. It's a high gamma value. So let me plot that also. I'm giving it a color hot pink. Let's see. So what I am observing, when my learning rate is increasing, it is not taking that long to reach to the minimum value. Can you see? When my learning rate was high, it was taking lots and lots of time to reach to the minimum. Can you see the difference? I mean, it's very evident. I guess you can clearly see that. This difference, what is this difference? This is the number of iteration different. I have a loss at 20 iteration. In this case, when I have a very small learning rate, I have a loss around this point. What was the loss around this point, which was around 20? Then I have a learning rate which is bigger than this. It was very smaller, this is bigger than this. So at 20 I have 10. In this case it's very low. Can you see the difference? Can you see the difference? Okay, I guess you have noticed the difference. Now I'm going to do an experiment. It is going to be very weird, but yeah, let's just do it. Let's see how it goes. So I'm doing an experiment. This is an insane gamma value. I'm going to give it to you. It's 0.25. It's a very huge number, 0.25. Okay, so, and again the guess is same, nothing has been changed, guys. Everything is changed. I mean, yeah, in some cases the guess is, I mean, like a 3 and it's 3, 1.9. If you want, you can keep the same as well. That's not a problem. You can play with that. So see what happens when I have a huge gamma value. See, can you see this? It never touches, I mean, it never touches the minimum value. It shooted over that. So that means I have certain threshold for the learning rate that I have to keep in mind, that it should not be that much larger or it should not be that much smaller. There is a certain threshold that we have for the learning rate. If we decrease it a lot, then this is going to happen. If I increase it, then it is going to go in a particular range. It is going to follow a certain range and never going to come to a point basically where its cost is low. So do you guys follow this or not? I know it is a lot to digest. It's a lot to digest, to be very honest. It's a lot to digest, but looking at the time that we have, I mean, that's the best I can do from my end. But yeah, you need to, it will take some time for you to digest all these things, because lots of information has been bombarded in a very short period of time. So obviously it was tough. I know, I clearly know that. How to decide? See, we cannot, we have to use multiple values and then we decide. So this again this thing is, if you're thinking of creating your own algorithm, so obviously these are the challenges you will be facing. But see the advantage that now you will understand the importance of libraries. This gives you the importance. That means these libraries, they take away all the hard work from you. You don't have to actually do all these things. You just have to simply call the algorithm, change the value. You don't have to go and write this huge codes. I mean, no, you don't have to do that. There are libraries that are already available for it. You just go pass in the parameter value, just simply get the output. You don't have to worry about all these things, how this value is, but you should have understanding how these values are affecting. You are never going to code it on your own. Never. Don't try to do that. I mean, if you want to throw yourself in a well or a hole, deep down hole, then obviously you can, but I would not recommend you at this stage to do this thing. This is just to give you intuition how all these things are affecting, how the step size is affecting, how the learning rate is affecting my model. And that is why we use library. Now, I guess at the first place, when you heard about library, yeah, you thought, yeah, there is something, yeah, that's fine. What do we do with that? What is so important about them? But now I guess you've realized the importance of libraries that we have. I guess you realized it. If you haven't, I hope you do someday. That there is the libraries that we have, they are very important to us. I mean, they are very, very important to us. So if you have any questions, guys, please ask. Otherwise, we can wrap up the session. I had few more things to show you, but yeah, I mean, I guess we have a limited time. So yeah, few things can be covered in this special time. So I'm sharing the notebook with you right away. You can go and practice this and tweak around with different parameters and then see what exactly you get. If you have some questions, then you can ask me. And the thing I don't like about that you guys don't ask questions, and I feel like I'm talking to a wall, and I feel there is no response that I'm getting in return. Whether I don't know whether you are understanding what I'm trying to teach you or not, because there is no response coming. Only Ajay gives sometime response, Sunidhi gives sometime response, sometimes Syed do, but not all of you. I need positive responses. If there is negative response, obviously give it to me, because nobody's perfect. Maybe I'm not perfect, I'm also making some mistakes. So if you could tell me what is the mistake I'm making, how should I go about it? Definitely I'll work on it, definitely. But if you'll not come up with the your feedback, if you'll not give me that, then there is nothing that I can do to help you. Okay, so I guess that's it from my side. So thank you so much for your time, guys. So tomorrow we will be discussing about the deep learning concepts. So again, it's going to be a little tough, but now you have seen this chunk of code, so I guess you will be able to understand the deep learning concept way better. So same thing goes with them as well. They do have a different type of functions. It's all mathematics, guys, to be very honest. With deep learning, with ML, it's all mathematics. Mathematics put it in the computer. Equations are coded in the computer already, so they solve it and give us the answer. The scientists, we need to give them kudos to those guys from the scikit-learn, from the guys who did coded the pandas library, the numpy library. I mean, Ajay, it's like there's a lot of thing in mathematics that you need to work on. I mean, partial derivatives are there, then we have projections. There are so many things. I mean, algebra, few of the things, so many things are there. I mean, that you need to start with. Okay, guys, so thank you so much. Calculus, yeah, calculus, linear algebra, yeah, absolutely, yeah. Calculus is important. I mean, linear algebra, then equations, different equations you have, how the polynomial equation work, what is the graph for it, all those things, geometry, a part of it. But it is for your intuition, and it's not necessary that you should know everything. It's not necessary. It is just to give you an intuition that it's not for you. It should not be a black box. That what is happening behind that algorithm. It should not be a black box. That is what I try to give you, the intuition. And if you want to go deep dive into it, yeah, you're welcome. You can go and always explore things. But yeah, but it's not important that you know everything of the mathematical aspect of the ML and deep learning algorithm. You should have the basic understanding. The intuition is required, and that's all it takes. Okay, guys, thank you so much. Thank you so much for your time. Have a good day. Bye-bye. Thank you, Ashima. Thank you so much.